So first off, thanks for being here. There are lots of nice talks next to this one, and I'm actually sad that I have to have this presentation and can't attend these, but I really appreciate that you're here. So working for a faster world, accelerating data science with fewer resources might sound a bit obscure, and hopefully you read the description as well, because mostly we are talking about a framework called Panel today for creating dashboard apps out of Jupyter Notebook applications, right? So yeah, I hope you're not disappointed. So a few words about me. It's Max. I'm a software engineer at UL Solutions to be. Oh, there's not. It doesn't show yet. All right, thank you. So I'm a software engineer at UL Solutions, and my question for you guys is: have you heard of us before? UL? Anybody? Oh, my colleague, yeah, obviously. So yeah, we do care about regulations, we care about safety. So whenever you use an electric device, I guess that's the best example. If you look at the power supply, there might be a logo done by us through some laboratory testing process or something like that. So that's maybe where you might have heard them from, but I haven't heard from them before I started working there, so it's no surprise to me. So, yeah, let's look at the agenda, what I want to talk about today. So first things first, I want to talk a bit about tooling. So we work with JupyterLab and obviously the framework called Panel. I show you some of the cool command line options they have for that particular framework and how to get most of it for speed. Next, I want to show you some key points regarding monitoring and profiling, how to check your panel app. And then I want to show you some of the more interesting stuff on how to improve responsiveness for the user. I also want to give you some pointers on how to optimize your data science application that might be specific to Panel in some ways, but also in general. So I hope even if you're not working with Panel or not going to, maybe you've been using Streamlit or Plotly's Dash framework, you can also apply these there. Yeah, let's get into it. So this is more or less the tool chain I'm going to talk about. So I guess you have heard of Python. It's the language we love and use every day. So it's also used obviously in data science a lot, data analytics, AI, machine learning. And yeah, in the field of data analytics, it's really nice because it's super flexible, right? So other toolings have their limitations. If you're using Python, it's super easy to just get whatever you want. You can build it yourself if there's nothing out there. JupyterLab, I expect most of you have heard from it before or have used it even. It's basically a development environment for Jupyter notebooks. You can write your code documents there and execute them cell by cell and have immediate results, right? So data scientists like to use it as well. Also, they use different tools and languages, but JupyterLab is kind of popular, I would say. And yeah, it's also good for sharing code. So you can use in a cloud-based solution there and have a server where you're using it with different users all together, so you can also share your code, right? Jupyter Notebook is like the main document type there, so that's where you write code. It's also not only for Python, but you can also use different languages. So Panel, maybe you haven't heard of that one. So it's basically a framework for building dashboard applications, right? This is like what they have on their website, development of robust tools, dashboards, and complex applications. You can use it pretty well to visualize some data. You can communicate cool things that you found out when analyzing your data. It's just a good way to bring the point across, basically. And it's not only Panel, but there is like a various set of tools there by the whole of this ecosystem. So it's a group of developers which also have a solution for visualizations. They even have several. And also Data Shader, for example, is for big data. I think they also have GeoViews, which is like a HoloViews adaptation to geospatial data. So it's not only one tool, but many actually. So yeah, let's keep going. So how do you actually develop a panel app with Jupyter Lab, right? So you first have to import the panel package and activate its runtime extension so it properly displays everything in the Jupyter notebook. And then you can make use of everything they have. So they have lots of widgets, they have lots of panes. You can basically have everything you want there. That's why it's so nice to use. It's really flexible. You can have like a basic markdown element there, but you can also go and embed your own visualizations. We also have many solutions for layout. So they have rows and columns, but they also have grids. Yeah, check them out. And then you can, while you're developing, immediately preview parts of your application inside of a Jupyter notebook, right? So that's what it may look like. So here I'm importing the panel package, I'm activating the environment, and I'm just creating a small markdown pane and displaying it in the browser. Right. So next, you want probably to serve it in some way, not have it in a notebook, but people who are not code affine might rather want to look at just like some visualizations or a dashboard, right? So how do we do that? So in panel, you can use the servable method to basically expose the whole thing as a server. And you can either then use the preview within the Jupyter Notebook or Jupyter Lab, or you can also preview it in a specific own dedicated browser tab. But that's still like a preview feature. And if you really want to serve your app, you have to use a command line, obviously, right? So you can call panel serve with either a notebook or a Python file, right? So that's how it looks in the browser. If you're starting the server, you have some of the server output there, and also you have what you're seeing in the browser there. It's a really simple example, obviously, to show off that it just renders Markdown here. All right, so I did some work for you because there are lots of arguments to look at. It's a bit of a wall of text there. So if you call panel serve with the help option, it will basically show all of this. But you probably want to know what's interesting to us as developers and caring about speed or responsiveness, right? So you can pre-execute the session, so it doesn't execute all your code just when you're accessing the server, but does so immediately when you start your server. You can use this argument, reuse sessions, to also not always re-execute basically your whole code whenever you're re-accessing the website, right? And also what's really nice, and we'll look into this more, is the admin endpoint you can enable with the admin flag. So they have various kinds of loading spinners in panel, and I will talk about this later as well. But you can also enable a global loading spinner. So whenever you're first accessing your application, it will just show you a loading spinner. I guess that's like to be expected, but you have to manually enable it. All right, let's go to monitoring and profiling. So I think one of the key points to pay attention to is how slow your code is, right? If you're running slow code, it will make the whole application probably at some point at least slow, right? Either at the launch time or during using it. So what you can do is, for example, use the execution time extension there is for Jupyter Lab. It's pretty convenient. I like to always have it enabled, actually. So it shows you how long a specific cell takes to execute in milliseconds or seconds, so it's even human readable. It's pretty nice. You can also use the timeit module. You probably heard of that one. So there's magic comments in notebook, so you can either use the percentage time sign and time it, or twice the percentage time, depending whether you just want to measure single Python statements or the whole notebook cell. I just think the extension is really nice, and I can just recommend it. So next, they offer an admin panel I was talking about earlier, and it only shows if you're enabling it through the command line options, right? So you can use it like this, and it will show you this view where you can switch between the tabs there. So what it does, it shows you not only the aggregated information of all your sessions that are running, the consumption of memory and so on, but also specific to single sessions. It gives you information how they are running. You even can see some plotting there on when it was accessed by some session or the other. It also contains server logs, so you don't have to look up your Kubernetes logs or your terminal console, but you can even access them there, which is kind of convenient. They offer support for free profilers, so you can just enable that through the command line option. There's PyInstrument, which is kind of rather rudimentary, I would say. SnakeWisp, which builds on top of that. And what we've been using in our project more or less the most often, I would say, is Memray, since it focuses on memory allocation, and we've been having problems with that. You just provide it as an option when you call the panel serve command, right? So that's what it looks like. It gives you information about the calls, how long it takes, depending on which profiler you use. The nice thing there is that it's integrated and it's supported by panel, so you just have it integrated into this admin panel and you don't have to care about anything at all. You have to install it, obviously, to make use of it, since panel doesn't offer it by default. What you get there is two kind of profiling sections there. For one, you have the launch, so when you start up the applications, but also you can measure specific calls, right? So if the user is clicking on some button or something, then you can use a decorator to access this specific part. And another thing that I want to highlight here is that it's really nice to outsource your code out of the panel application and have it in certain specific Python files, right? So you can use further tooling that is for the whole Python ecosphere, right? And not only be limited to Jupyter or Jupyter notebooks, right? So that is also a thing for unit testing, for example. So let's talk about responsiveness. So I think a key thing here is to have something immediately, right? So if the user accesses the dashboard app, you obviously want to have something immediately loaded up, so the user doesn't wonder what's going on. Okay, I close my tab where it's taking forever anyways. So what you can do is initialize all your elements with empty data, basically. I think that's a given, actually. You only have to understand how your format will look like, or if you're dealing with a table, you obviously have to care about the structure and the columns beforehand, right? So if you're using the tabulator widget, which is really nice, it comes with a lot of features there. It basically wraps the JavaScript library tabulator, if you heard of that. And it uses, at least the implementation from panel, a pandas data frame. So you can just give it an empty data frame. If you know your column names ahead of time, it's really nice because you can just basically render your table how it will look like, but with 0 elements. The same goes with plots. I want to see something immediately, even if it takes some time, or even if I have to make some interaction to get data actually loaded into the plot. It makes sense to initialize it empty and just show it to the user so they feel a bit more relaxed that something loaded at least, right? I was talking about the loading spinner earlier. The command line option is just when you launch the panel application, basically, right? But panel has a widget for loading spinners, so you can just place it on top of anything you want. But also you can just set the attribute, I think it's called loading, to true or false, and it will also give you a loading spinner, which is super nice. So whenever you're updating a table or a plot or something, you can just set that and you have some animation. So something nice about panel is also the onload function. So we realized that first, before anything gets rendered, the whole notebook is executed, right? And whenever you have some heavy lifting or something like that, you may want to delay that. They have this on load, and if you do some heavy lifting there, maybe some operation is really expensive and takes a lot of time, it's reasonable to offload it to this function, and it will basically start to be executed after your initial render process, which is kind of an inexpensive thing to do. And then I have some other recommendations based on panel. So besides that, you can also use caching. So it's also more or less built in. You can just use a decorator for a function that you call repeatedly with the same arguments in the same situation. It will take off the work for you to cache it, which is super nice. And streaming is a big thing. I don't have any example for that one, but obviously if you're dealing with live data or just a big data source, there are several options. I worked a lot with the tabulator widget, as I was talking about, and this one has, for example, pagination, and you can have it cloud-based, so your front end isn't loading all of the data, but whenever you switch between the pages there, also a certain section of your data frame or whatever you have on your end gets loaded. There's also lazy loading. So they, for example, have a layout. I think it's still called a widget there in their ecosystem, but you can have tabs, right? So you can switch between different layers of your applications, which is pretty good for orchestrating a nice dashboard, I think. And you can set the dynamic to true, and then it will just load the immediate tab, and it might also be more responsive for your use case. Also, which is pretty much a given whenever you're dealing with a huge range of numbers, for example. They have sliders, for example, and you can select a certain data range, for example, a date range or some certain numbers to pick from, and you can throttle them. So not always whenever you pick it with the mouse and you drag it around, for every tick it gets fired and immediately slows down your application. It queues up certain events, and maybe your visualization might even flicker. So that's also a given that only fire or trigger calls whenever you let go of your mouse, right? There's a nice cheat sheet I want you to check out. They basically have this information on there and a bit more. So what I also want to talk about is some general optimizations. They might be applicable to other frameworks as well. And what I think is pretty obvious, but you have to remind yourself of, is what data do you actually need? If you have a big data set, you obviously don't want to load all of it, even though you won't need it, right? So I advise you to create a subset specific for your dashboard application, and then also maybe evaluate whether your generality is meaningful. Do you really need every microsecond of your datetime format or not? Maybe hours or days is enough, right? And also, you want to do the heavy lifting beforehand. When we first started using Panel, we did everything in a single notebook, preparing the data, cleaning it, and even doing some acquisition tests there. That was really slow because you're doing all in one workflow, right? So what I advise you to do is outsource your process and do the data acquisition, the cleaning, the preparation, do it all beforehand if you can, right? Also, you want to pay attention to your data types there. If you're dealing with strings, if you're dealing with numbers, set them up beforehand. It's really valuable when you're using different frameworks that are specific for specific data to also have it in the right format. I think it's also obvious if you think about it, but building this kind of notebook as a panel app, you sometimes forget about these things, right? Oh yeah, animation. So before there's showtime, you want to do all the preparation. So I also want you to use dedicated Python packages depending on your needs, right? So I guess everybody has heard of pandas or NumPy, and the obvious thing where whenever you're using it is that you're not doing Python style for loops, for example. If you have a huge data set and you're going through every row by yourself, it's obviously really slow. There are specific tailored packages with high performance to do this. So I think Pandas and NumPy is a good example for this because we have specific methods for applying a certain function, a specific change to your data set in an efficient way. If you didn't know, these packages are written in C, so they are really fast. They are not written in Python natively, but only expose the Python wrappers to Python itself, right? Oh, let me actually talk about some other packages. I've written it here. So also, I haven't used it yet, but Apache Arrow is really good for columnar data. Like if you are dealing with the Parquet or the Feather format, it's really nice to use. There is also Dask for parallel programming or parallel computation. And what we found out, because we were working with a data set with geospatial data, there's even GeoPandas. I don't know if you've heard of that one, but it's dedicated for geospatial data. And another thing is that you should really care about your data, how it is stored, and how you access it. So there are our obvious types of formats we use as humans. Probably all of you had to deal with Excel. We sometimes work with CSV or JSON. Whenever you load, whenever you read something like that in your notebook, it might be fine for you with like the speed and memory consumption of the whole loading process, but it might not be for your dashboard app. So there are a couple of things, a couple of formats that are focused on performance. I mentioned Parquet and Feather earlier with PyArrow. Apache Arrow, basically, and there are other ones. So really easy to pick up. There is Pickle, for example, so you can store, serialize your data in a binary format, and it loads way, way quicker. There are even some threads you can look up where it shows you the comparison times between the read and the write commands between different formats. Obviously, if you're dealing with a large data source, you want to use a database. Only load a section of your data set, and yeah, that's basically what you want to do whenever you have a large amount of data. So yeah, that is my end. Do you guys have any questions for me? Yeah.
Sorry if I missed like part of the presentation, but so you proposed this panel for your data visualization. I missed the part. Is it interactive at all?
Oh yeah.
That's one question. And the other one, is it just a substitute for like Tableau or other superset or other visualization tools?
Thank you for the question. So yeah, what is it? Basically, I guess this talk is not the best for talking about panel overall, what it is about, since I'm not an expert on what the other tools are. But basically, whenever we see someone using Excel or Power BI in our company, something like Tableau, we try to convince them that we have a better option. We have more freedom, we have custom solutions. Obviously, whenever we deal with some request on an insight or something like that, it requires a data scientist, right, to write code, and that's maybe a disadvantage, but we are way more flexible than that with Panel, for example. We also looked at Streamlit, for example. I was talking about it earlier, or Plotly Stash. I think they are inferior, but yeah, basically like that. I even have an example I might show. I don't know if it's if I can put it up here on the screen, because we have used one of our panels in a webinar recently. Oh, I think it's working, right? It might crash the server at first and I have to wait for 20 seconds, but you know. And we have a couple of visualizations there, which might be nice to look at. If there is any notification popping up, then that's a bad sign for a few seconds. Let's hope for the best. So this is Airbnb data. It's Airbnb Berlin listings. And for example, we have a tab here with the tables. So you can look at the tables. We wrote this just as a demonstration for us or for some clients. Oh yeah, time is up. But let me briefly show you the static plots here. So this is mostly using Seaborn. These are not interactive, but we have also in this demo dynamic plots. So this is like a folio map, for example, you can play around with. You can also have widgets. We are really basic here, so you can just type a specific type of room here, or a heat map. We also have, I think, we built in some interactivity, so you can here you can select the backend, for example. It's agnostic to the backend, so you can use either Bookie, Matplotlib, Plotly, whatever, many more. Or here, for example, we have some sliders that will also refresh the whole application. I'm not sure how fast it is because maybe the server crashed. Oh, it works. So, for example, you have a daytime selection field here as well. So yeah, there is interaction. But maybe there should be another talk about panel in general. Thanks.
Okay,